is writing it as 9c over 5. That is because 9 over 5c refers to 9 over 5 times c, which c is c over 1. So numerator times numerator, denominator times denominator. So they are equivalent in representations. Okay? Having it written this way, it is much easier to handle because f minus 32 over 1. Okay, we will be able to do our cross multiplication. Hence, I will have 5 times f minus 2, okay, equals to 9c. And because I want c to be alone, I need to divide the 9 over. Hence, I will get my formula with the subject as c to be 5 times f minus 32 over 9. Okay, so this will be how we arrive at the answer. Any questions? So please check your own work. Okay, you can expand it, not a problem, right? It's equivalent. Next, we have question 6c. In question 6c, we have s equals to ut plus half at squared, for which we want u to be the subject and u is found over here. So what should we do first? What should we do first? Dylan? Sorry? Times 2 everything. How many of you would do that times 2 everything? I don't think it's necessary for us to times 2 lah. Okay, you can do that, but it's not necessary because our objective is u. We can bring this entire term over to the left already. Right? So I will have s minus half at squared equals to ut. Okay? But then again, at this stage, next we need to divide by t over to the left, right? Okay? There are a few ways to get around this. Okay? Because when you want to divide by t over, and you think of writing it this way, there's a problem because you have a fraction within a fraction itself, and that is not considered simplified. Okay? So what we need to do to think about this fraction over here, you can think about it as s over t minus half at squared divided by t equals to u. Okay? So for example, if you think about our numbers, 5 minus 3 divided by 2, I hope you recognize that it is the same as thinking as 5 over 2 minus 3 over 2. Same idea in our numbers, right? Okay, so I'm just separating out into two separate fractions, s over t minus half at squared over t. Now s over t itself, nothing wrong, okay, nothing for us to further simplify. For the fraction on the right, we have t squared on the numerator and t the denominator, for which I can divide t on both the numerator and denominator. Okay, and then we will be able to have minus half at. Because denominator t divided by t is just 1, there's no more denominator to mention. In the numerator, okay, you will divide by t, and such that you will be left with only 1t. Okay, so you can get your answer to this, for which u equals to st minus half at. There are many ways to represent this, okay, many other equivalent forms. So long as you are able to balance the equation on both sides whenever you deal with something, and that is mathematically sound, and that will be fine. Okay? Maybe I will give a try to what Dylan was suggesting, which was to multiply by 2 throughout. Nothing wrong with that. So when we multiply by 2 on both the left and right, I'll get 2s on the left. And on the right, I'll multiply 2 to the entire thing, for which I'll get 2 ut, and then 2 times half at squared. 2 times half is 1, so I'm just only getting at squared. Okay, so I'm going to be arriving at this. It is important that we are able to distinguish the t and the plus, because if you don't distinguish the things, it is very difficult for us to be able to read it. Then, upon having this itself, with you wanting to be the subject, okay, we can move the at squared to the left, followed by dividing 2t over, because this is 2 times as well. Okay? So either of it is acceptable. Questions? Okay, next we look at question 7a. A blue color table. Maybe this one. Which class? 108. Okay, remember the written here. Okay, remember this boy borrowed from 108, then they purchase something. Okay, so we have 1 over h plus 1 plus 2 equals to k. So now we want h to be the subject. So in this case, what will we do first? What will we do first? What will you do first? Sorry? Okay, bring the 2 over to the other side, right? So I'll get 1 over h plus 1 equals to k minus 2. How do I bring the h out from the denominator? What can I do next? What do you mean cross multiply? What do you mean multiply now? Okay, bring it over to the other side. So we think about it as cross multiply. Okay, so 1 times 1 is 1, and then we have k minus 2, the entire thing as a group multiplying with h plus 1. Should we choose to expand? Should we choose to expand? Okay, I don't think it is necessary to expand because it will get itself to come as 0. Okay, keep in mind we only want h, so I can just bring the k minus 2 over to the left, which will mean 1 divided by k minus 2 equals h plus 1. Then I can actually minus the 1 over, so I will have h equals to 1 over k minus 2 minus 1. Okay? You think about it, if your answer is different, are they equivalent? Okay? Now how do we check for equivalence? Let's learn a new skill. How do we check for equivalence? How do we check our answer? Any ideas how to check? It's important that we know how to check, right? Correct? Okay. How do we check in this case? Now, you're given a formula over here. Alright? So let's say for example, I let h to be 2. I anyhow choose this number 1. You can choose any number that you want. Just don't choose special numbers like 0 and 1 because sometimes they have a certain effect on the formula itself. So I think 2 is quite a safe number. And then when you place it into a calculator for 1 over h plus 1 plus 2. Okay, what do you get in your calculator? You won't be pressing 1 over 2 plus 1 plus 2. So this is 1/3 plus 2. Make sure you try to get an exact number. That will give us 2 and 1/3. Okay, so you are trying to see over here that k comes out to become 2 and 1/3 when h is equal to 2. Okay, so what you can do to check is that in this final statement over here, you let k to be 2 and 1/3. Okay, let k to be 2 and 1/3. Press into your press into your calculator for this entire thing here and see what is the value of each. So when k equals to 2 and 1/3, press your calculator. Okay, you should be able to get 2 back. Because it doesn't make sense if down here you let h to be 2, k becomes 2 and 1/3, then you do the other way around, something different returns back to you. Okay, so that's one way for you to check whether your formula, your eventual answer over here, does it make sense or not. Okay? Then after that, find out what is S. Then do the reverse. Okay, for your eventual answer. Questions? Okay, so that's one way to check out. Then let's look at question 7C. Formula. So we find that P is found here, likewise here as well. Okay, the skill that we have learned is that we need to bring the P's together on one side of the equation of the formula and then factorize out the P. So since I have my P over here, I can maybe bring it to the left first so that all the things that are associated with P are found on one side. Since P is on the numerator, and this is actually P over 1, I can factorize out the P to say P times X over Q minus 1 is equals to Q. Then I need to divide this entire expression over to the right, but it can be challenging because I will eventually be getting a fraction within a fraction, and that is not simplified. So how do we deal with this? Okay, what we can do is that please make sure you present it properly such that your long fraction line and your short fraction line are distinguishable. The denominator over here, we have x over q minus 1. I can make the things in the denominator share the same denominator of q. That will mean that I have x minus q on the numerator. So, I want us to be able to observe what I'm doing here. This denominator over here, I have transformed it into this. Okay? And then from here, right, this is q over another fraction. This fraction line that I have here is the same meaning as division. So I'm taking q divided by x minus q over q. For which I know how to divide a fraction. I do my keep change. That will give us q over x minus q. So numerator times numerator, this is q over 1. That will give us q squared. Denominator times denominator. So therefore, P is equals to q squared over x minus q. b over pi r squared minus 2 over 3 r equals to h. This is the denominator moving on. Okay. So this could be a way to solve this problem. Alternatively, you can do what Dylan was proposing earlier on, multiply across by 3, so that you don't have to handle a denominator at all. But just now for this question, Dylan suggested multiply across by 2. That's also perfect. Okay. I'll just do 8 part A. I believe 8 part 2, I'll do 8 part 1. 8 part 2 shouldn't be a problem. Okay. So 8 part 2 just place it inside the formula. Next, 9C. I think I'll just go through all. Subject, and x is found inside the bracket where there is a square on the outside. Okay, so what should we do first? Isa, what do you think we should do first? What will you do first? Move the brackets over to the other side. How do I write that? Okay, then what next? Vina needs a base, is that what I do? Move the y. Okay, then what do I write? Okay, actually you just move the q over. We maintain this to be positive as much as we can. Okay. So yeah, then this as well as whatever you were saying, which is x minus p squared equals to y minus 4. Then are we okay with this answer? Yes, Divya?
It's both positive and negative.
Should have both positive and negative, right? Okay. So Isan, what's missing in your answer is when you square root, you need to have both positive and negative. Okay? Yeah. So please make sure you put in the positive and negative sign. Okay? So what this actually comes out to become, actually there are two forms of the formula. The positive square root form or the negative square root form. So this is what it means. Okay, but of course you can just put it in a neater, condensed manner by having it presented in this way. Okay, rather than to express it like that. Okay. In this way of expressing, it is to help us understand what this means. So that in case we need to calculate by putting numbers inside, we know what to press in our calculator. Because our calculator does not have this symbol. We need to calculate it separately. Okay? Last one, question 11. 11, we have t equals 2 pi square root L over G. I'm pretty sure I went through this formula before.
Is the same as one of
The one in the worksheet, right?
this worksheet.
Yeah, lor. Okay, so if you understand the worksheet, I have definitely gone through this before. In this case, we want to make L the subject. Okay, so this actually means 2 pi times square root L over G. So that is like a hidden multiplication sign over here. So I want my objective to be L. I get rid of 2 pi first by bringing it over to So I'll have 2 over 2 pi bracket square equals L over G. Right? You may choose to expand this, make it as T square over 4 pi square. But at this juncture, maybe you don't know your indices rules very well. Okay, there's a set of rules for this. Okay, otherwise you may just leave it as this. So I need to have L alone, so my G needs to be brought over. So I need to multiply my G over to the left. Therefore, I will get L equals to G times T over 2 pi bracket square. Okay.